Good morning, students. So, our today's topic is drilling size for holes. So, this is the part of 7.6 module, but this is not the necessary why we are studying this topic. The main objective is to learn the correct size of uh, drill utilization, drill bit utilization, to identify or to marking the perfect size of hole, right? So what drill bit size makes how much diameter of hole, we will learn in this topic. It's very interesting, and this is one of that kind of the topic which we generally uh, do the practice on the same. So the size of hole to be drilled depends upon the purpose of the hole. So this is most important thing which we must have to be learned. So suppose if I am taking a same diameter of the hole, but if its utilization is to um, insert a rivet, right? So we will make a different diameter, and if we are going to use the screw, then it should be different, because I'm going to make a drill, and thereafter we have to make some threads, inner thread to install the screw. Then size will be different, and if we are using the plank shank of a bolt, then it will be different, right? So try to understand. So if the purpose is to make the outcome diameter is same, but the processing of making the particular kind of hole size will be different, right? So suppose if I am going to be install a shaft on a hole, then we will keep in our mind the shaft and hole combination. That means I'm talking about the allowance in between the shaft and holes, right? So we will keep concentrate on the allowance, and then we resize the hole. And if suppose that if I'm using the reamer, so what is the purpose of reamer? To increase the bore size, right? So if suppose I have to apply the reamer on the hole, then the size will be little bit smaller, right? So that the reamer can cut the required material. So in short, uh, I would like to say that if the purpose of the hole is different, then the processing of the hole size will be different, right? This is the hole size chart, and this is the metric system. Sorry, it's the English system, right? So on the same way we have the metric system. You can find out from the website, and also it is given in the cap. So if I say that the drill size is 107, the diameter is this, 106, the diameter is this, and if you see, when we are reducing the size of drill, right? So it is increasing in inches and the size is increasing, means the maximum size of drill bit shows the minimum diameter, size of the diameter. A clearance of fit and standard. So we know that we have three type of the classes. I'm so sorry. The topic is classes of fit and standard, right? So we know that we have three types of classes of fit. One is interference fit, transition fit, and clearance fit. So we are aware that because why I'm saying that we are aware, because in last topic we have covered this earlier. So in the interference fit, where the shaft is larger than the hole. For transition fit, where the shaft and the holes are approximately the same size, and for the clearance, uh, it's the shaft is smaller than the hole. The clearance always allow you for sliding and rotation, right? So interference when the transmission of force is required, and the transition fit is the combination of both the interference and the clearance. We have already done this part. So now basically we have two kind of standard to explain the fit. One is the naval system and one is the British system. When we talk about the naval system, so in the early naval hole-based system of limit, the hole are classified as class A and class B fit, right? So there are two types only classes. We have one is class A and second one is class B fit. So class A holes are manufactured to a closer tolerance than class B hole. That means जो class A होता है उसका tolerance is closer than the B. And when we talk about the shaft, then it is utilized by F, P, D, X, Y, Z. So we have six later we can use. So this table will make you better understand for the shaft. So if we have class fit F, so it is known as the interference fit. So type of fit is what? Is force. Why it is force? Because in interference, the shaft diameter is greater than the hole diameter. So you are trying to insert a larger diameter thing into the smaller. So obviously you will apply a lot of force, right? So come to its remark. So the mechanical pressure is required for assembly, and once assembled, then no dismantling is likely to be required, right? So it's a kind of the permanent type of fitting. So once you inserted the larger diameter shaft into the smaller hole, then what will happen? You require lot of force to get inserted. So obviously, if you have inserted once, so it should not be in general practice that you are going to be removed and then reinserting again. So think that it's a kind of permanent fit. If the class of fit is D, that means it's a driving type. So for driving type, so these are a little less tight than the force fit, right? So it is also the interference fit, but respectively the shaft diameter is smaller than the F type. That's why it requires less force. And one the part can be driven into the other. So एक पार्ट दूसरे में आप इंसर्ट कर सकते हो, दूसरे को तीसरे में इंसर्ट कर सकते हो. इस तरीके की आप सीरीज फ्रेम कर सकते हो. नेक्स्ट इज द ट्रांजिशन फिट, जिसको हम P टाइप कहते हैं, एंड इट इज आल्सो नोन एज पुश टाइप. So its slight manual effort is required to be assembling the part and suitable for deattachable and locating the parts, but not for moving part. So think in this way, when something is required which says very less type of force, right? So or we can say that the tolerance is, sorry, when we say that the size of shaft and the size of hole is approximately same, right? So then there is a transition fit. So transition is actually a combination of both the clearance and the combination of clearance and interference. Now clearance. When we talk about the clearance, that means there is a air gap between the hole and shaft, right? And it always allows you for sliding and allows you for the rotation. That's why it is also called the running type. But its assemble is, oh sorry, its identification alphabet is X, Y, and Z. So suitable for the various type of the moving part, and class Z provide the finest fit. So class Z जो है that provide the finest fit than the X and Y. Right? I hope it is clear. So this is the naval system for fit. Now come to the British system, standard system. So there are so many systems which we follow, but the generally main system which is that is the BS 4500 system. So somewhere also there is a following of the ISO system, but here I'm trying to cover only the British standard system. So the British standard system will be a system of fit. Then you have to refer the uh, given figure. So where is the figure? This is the figure. So this is the interference fit, transition fit, and trans fit. So it is almost equal to the basic terminology of the Boolean shaft, or it is the similar to the used for the naval system and several other systems. It can, however, be seen that the interference fit, the upper and lower limit of the shaft are greater than the corresponding limit of the hole. Right. So the same thing which I told you earlier, that in the interference fit, the size of shaft is greater than hole. That's why it shows that the upper and lower limit of the shaft is greater than the corresponding limit of the hole. The transition fit is the different in the upper and lower fit. Both items are negligible. That means it is almost same. And for clearance, the upper and lower limit of shaft is less than the hole. Less than the hole. So this is the diagram. We will discuss in next class some more standard like ANC standard. So I was trying to find out the good literature. So I'm still on that way. So once I get it, we'll definitely share with you. Now the schedule of fit and clearance. The schedule of fit and clearance. Right. So suppose you have a part uh, which are combined with the animal. So there are two things. Either there is a motion or either they are the fixed. So if they are fixed, now I'm removing this thing. Now we have to concentrate on the motion. Suppose if the motion is intentional, means they are designed and manufactured in that way that one part is rotating with the another. For example, the bearings, for example, the combination of the gear, right? So they are the intended, they have the intention for the rotation, right? So we have one of the motion like this, and one is the inattented or unintentional. So what is the unintentional? Means the parts formation and its you know its design or the purpose was to be get fixed, but they are moving. They are moving due to which thing? Maybe there is a high vibration that may cause of high vibration. That's it is moving. So if any part is intentionally moved or if any part is unintentionally moved, so there are chances to occur of wear, right? So wear can be occur in the both of the cases, but now we have to go through its acceptance, right? So if the parts are intended to move together, then there is a maintenance documentation. There is a pre-planned maintenance documentation that we have to check the fit and trains in particular time of interval. Right? And if the parts are not intended to move together, right? So at this time of period, we have an inspection procedure sheet, right? Which we follow particular time of interval also, or on the occurrence of the situation. So in both of the cases, we are bound to be maintain the things or follow the maintenance schedule. The schedule of fit and clearance obtained table will specify the limit of the wear and other characteristics. So there are four things which we will go through. One is the limit of wear, and second one is the other characteristic. And in the other characteristics, we have ovality, bow of shaft, and twist of shaft. So what is the ovality? So obviously the hole is rotating inside of a sorry. The shaft is rotating inside a hole. So when it is rotating, so there is chances the increase in the diameter of that hole. There is chances, right? So we have to check its ovality. Ovality means the oval shape instead of the circular, or maybe some another factor. So in short, we have to check the dimension of that hole, right, in a particular interval. Next one is the bow of shaft. So what is the bow of shaft? Bow of shaft is nothing. It's due to some reason if there is a bend in the shaft, maybe some load, maybe some other cause, right? So there is a band, right? Bow is bow shape, like a band, right, of the shape. And second one is the twist of shaft. So suppose if we talk about turboprop shaft, so in turboprop, the propeller is rotating, and that shaft is also facing its counter force. So one side is rotating towards the clockwise, the counter force is always trying to rotate it into the anti-clockwise, right? Right. So that's why there is a chances of the twist in the shaft. We will discuss this part later on. So now come to the limits of wear. So when we talk about the limits of wear, so we have to take care about these 4 points. One is the dimension new, the permissible worn dimension, the clearance new, and the permissible worn clearance. Now come to the first part, which is the dimension new. So dimension new relates to the size of the part when new and will show the uh, relevant tolerance. Right. So this is when we consider when the things were totally new, right? And what was the measurement? Then we will keep it for our reference. Then we will check the permissible worn dimension. Permissible worn dimension means after being in working condition for a long time period. Right now the situation is changed. Now you will again take a dimension of the things, right? The dimension of hole, dimension of the shaft. You will take, and then you will find and refer to the maintenance approval sheet or something manual that how much dimension they are permissible. So due to high speed of rotation, due to vibration may cause, right, you see that the size of hole is enlarged. Now you will refer to the manual that what is the size is permissible. Suppose initially the size was x mm and now it's something like x plus y mm. Now you have to think that this y is come under the your acceptable range or not. If it is under the acceptable range, then you will continue with the operation, and if it is not, then you have to change that part. That is required. You have to change that part, or will take the corrective approved maintenance practice to recover its almost new permissible dimension, right? So and right, so this is the thing. If it is comes under your permissible dimension sheet, then continue with the same, and if it is not, then take the required action. If it is a changeable part, then go with the change, and if it is non-changeable part, then try to follow the approved procedure to recover its original dimension. In the same way, about the clearance. So clearance new is the desired clearance in limit form, and the interference rate are quoted as the negative clearance. So interference means I'm talking about the power transmission shaft, right? When the size of the shaft is greater than the size of the hole, right? Now come next point, the permissible worn clearance refer to the maximum allowable clearance when reassembling the component. Again the same thing, you have to check the clearance limit. If it is under your acceptance, go with the operation, and if it is not, then you have to reassemble or you have to change the particular limit. So dear student, so today we covered these things, the breathing size, the classes of fit and its standard. Okay, so this is the table for the naval system of fit, British standard, and schedule for fit and clearance, right? So for the next class, we will discuss about the uh, ovality, bow of shaft, and the twist of shaft, right? So we can end the session for today, and please go with the same. And as our standard drill that we have a down session at 3 p.m. So we will discuss our topic if you have any doubt on that session, right? Thank you so much, and have a great day.